Yeah. So can you guys see my screen now? Can you see? Am I visible on your screen? All right. Good evening to you all. Today we are going to be talking about a very important topic, right? And it's one of the most important things. We are going to be doing an overview of what software engineering is and how software engineering works. Again, good evening to all of you. Good evening, Obadiah Emmanuel. Good evening, Bodua Tife. Good evening to you, Remo. Good evening, Musa. Good evening, Anna. Good evening to you, Augustine. Good evening to all of you that are available on the live stream that has come in early. Um, Today we are going to be doing an overview of software engineering and what it is, all that it entails. We are going to be learning a whole lot. Yes, a lot of you are still coming in. I can see Bello saying good evening. Yeah, good evening to you. I should be looking at these comments from my phone because my stream is a little bit, my screen is on one side. So we we are to do an overview of what software engineering is, like how to start, what you should be thinking, like, before we start writing code. In our next class, we'll be talking about interpreters and bash scripting. I know that all of you guys cannot wait for us to start learning and for you to start having a senior engineer point of view uh, program, being written on your phones and all of that. Um, from next week Saturday, we'll be doing that. We all be writing computer programs together to grow together as well. For now, we we are to be talking about a few things today. Let's see. Let's see. Okay, so I just put up my slides for this class. So we are to be talking about a few things. We want to demystify what software engineering is, have an overview, how you can start and what you can do. The difference. What software engineering is not just programming. That's why I keep talking. I keep trying as much as possible to educate you guys. You need to have an holistic view. So first of all, what is programming? As we all know, literally in this part of the world, what most learners do is they start programming. They tell them there's this notion that when you start writing a programming language, let's say Python, HTML, CSS, JavaScript, as the case may be, that you are now a programmer, you now start earning money. But then you realize that it does not work that way when you start. When you start doing that, you now realize that it doesn't actually work that way. There are certain things that you need to understand. There are certain architectural structures that you need to follow if you want to be a success in this line of work. So programming, think of programming as a bricklayer building a house, right? The programmer is mostly concerned with getting results, specific results, building a platform to a specific design, you know, generating a specific script, page, web page, workflow, as the case may be. That's what a programmer is. That's what most programmers think like. So a lot of learners have been trained to be programmers. And what this means is that as a programmer, you have a localized scope. You focus on writing functional, instructions, making the computer behave in certain patterns, generating a web page or designing a backend structure. It's a localized scope of what it takes to succeed in the software industry, right? It's 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 code centric. It's code centric. You only write focus on writing code. Sometimes they hire you as a developer, and what you do is, you write code, you build a backend, you build a front end, whatever you're hired for, you keep doing that, and you keep earning from the company. But it's difficult for you to scale, to grow, because you are not an engineer, you're not a software engineer, you're not designing pathway to success. For you to understand the pathways to success, you need to understand software engineering in its entirety, which is to say that you would realize that writing code is just an aspect of it. Many a times programmers are taught to write a certain language, and they are limited, very limited to that language, and that's because they are not even actually programmers. They are just taught. They only know how to write a programming language. They are not programmers. you know Programming, for you to truly understand programming, you need to understand concepts, you need to understand and implement all the foundational knowledge to the extent where you understand every single programming concept and can use it you know across programming languages. Because last time I was in a live stream with you guys, I told you that an if statement will always be an if statement. A function will always be a function, regardless of the language you're writing, right? So if you don't really have a strong foundation on the concepts and you know all the fundamentals, you will not be able to succeed, as a software engineer. You're not. There are no two ways about it. Recently, there's a wave of advertisements on the internet saying, "Hey, AI built you prompt Claude or prompt ChatGPT to build a website or an app for you." Okay, they can actually build a single page, few page app, for you. But are you successful? What does the app do for you? Do you know how to manage it? Can you? How is your deployment? There are like a lot of things, a lot of factors, and this is what software engineering is. On our slides, we are saying that software engineering is an holistic scope, right? So it considers the boundaries, operational scalability, performance metrics, and lifetime evolution. So a programmer is different from a software engineer in this particular way. A software engineer thinks about the program in its entirety before the job even starts. So there is a workflow. For those of you registered in the WinMingle training program, for those of you actively learning, you would realize that we are teaching a lot of concepts, and we are giving you a lot of assignments to ensure that you have played with the concepts in every possible way that you need to have played with it to fully understand the concept, right? When you get to your major projects, the project three, the first two projects you have to build is the printf and the simple shell project. But the project three is a full stack application. We are guiding you to build both front end, to build back end. But before we do that, there's a process. We are teaching you the software engineer mindset. There's a process. We are giving you the architecture first. We are teaching you about the architecture of the platform you have to build, how the platform works, how front backend is connected to front end. In fact, I think in the platform you actually build the backend first. You build there's like a base model that controls other models, other components of the brain, of the platform that you are to build as your third project. And you know, our goal is to ensure that you understand the architecture, the structural presentation of the entire product that you want to build before you even start building it, right? That's how software engineers think. We don't just think, oh, I want to build a business, let's say an e-commerce platform. How do I build an e-commerce? And you sit down one time and start writing code. That's not the way to success. You have to have it entirely planned out. So software engineering is life cycle centric, not code centric, right? Programming, coding is code centric. You just want to write code. But software engineering is life cycle centric. You have to code, you have to do reviews, you have to do testing, you have to do uh, debugging before your deployments and further maintenance as well to ensure that the platform runs in the desired way, the way that you have desired. And in software engineering, there's room for collaboration, right? Because of preparation. Now, see the difference. As a programmer that does not understand how to plan, how the system architectures work. When I talk about how planning and all of that, we are in this lesson, we are still going to learn how software engineers plan work before they execute, how they plan and execute the work, you know. And for now, I'm just trying to make you understand that programmers usually work as single individuals because of lack of planning. And software engineers could actually work in a team. We already taught you guys how to use Git, you know, how to deploy your code to GitHub. And usually, for you to work in a team, you have to push your code to GitHub, right? You have to work in separate branches and merge at the end of the day. So, how it works, collaboration works is on GitHub, where you usually submit your assignments, you create a branch for yourself. Let's say we are 5 engineers. uh, Engineer 1 and 2 are working front end. Engineer 3, 4, and 5 are working back end, right? And deployment. We 1 and 2 are going to create separate repositories for themselves, separate branches for themselves, where they would work independently. They would share their work. Let's say one of them is handling authentication pages, all the pages that has to do with authentication. A single engineer might be handling that. And the other one might be handling the dashboard and other builds. And when they are done, they both will merge their applications. You know, there's room for collaboration. The backend guys, somebody might decide to build the after planning. If you don't plan, you will not be able to work like this, you know. Somebody might decide to be building the base model. The base model function should be to call other models that, you know, solve other problems. And then they return all their endpoints, you know, they actually merge and return all their endpoints to every single product for the base model to call and solve the entire problem the product is supposed to be solving. That's how software engineers plan backend builds, and then they now connect the front end to the backend using maybe Node.js, whatever they want to use. To might be an XML call or something. They connect the front end to the backend, and that's the full. There's a functional program for the company to use at the end of the day. Uh, let's see. Can you guys hear me? Hope I'm audible enough. Right. So that's the thing about collaboration. Collaboration is very important in software engineering. Sometimes you work with somebody and you know you you cannot you sometimes debugging becomes easier when you're collaborating, when you're working with some other people, because errors that you don't see, some other person might just see it and it's fixed, right? So there are a few pillars of high quality systems, right? Every high quality system that you see, every high quality system that is built, that you use, the products that you use in your phones, they are high quality systems, right? They are reliable. So engineers think about reliability before they even start building, right? You have to account for it. You need to ensure that your system meets the required expectations, right? At all times, because that's how you keep your customers. You keep your customers by ensuring that your system is simple to use and it does not fail, it does not breach. That's how systems are being customers are being kept, or clients are being kept using to returning clients using software programs, right? So ensuring that your system performs to their expected functions continuously under varied and unpredictable hostile conditions and environments. Very, very important. You know, these are the mindsets of of software engineers. During the design period, when you start designing a product, we are talking as see, I'm advising all of you as people that I advised to not start this training without having a product in mind that you want to build. Hopefully, everybody in this meeting has a product in mind that they want to build, right? So, we are talking about that product that you have in your mind to build, that very scalable product. You have to design your design. See, currently, nobody should even be writing code in this meeting about the product that they want to. Nobody should even be building the product that they want to own without doing paperwork, a lot of paperwork. I have my booklet here just beside me, and I work so hard with it. I've written on almost every page. I have a lot of books around. When this one gets filled up, I'll go get the next one. So that's basically how it works. A lot of planning, a lot of, you plan for data management. Okay, let's talk about it. Let's talk about unexpected conditions, right? Recently I was doing a job, and it was on a GPU, right? And I was monitoring frames for video generation, building one of these your current video generation AIs, and there was something really minute, right? That I had to handle. It was very small, but it was very important. Considering network conditions, should in case the data available, the network available from a device is not able to pull in as much frames as I wanted, I still wanted the computer to catch the available internet speed and still pull in at least that amount of frames to reduce. If you know something about GPUs are usually slow. They are not as fast as your CPUs, but then they could process tons of parallel data, much more than your CPU can, right? So while your CPU has like let's say 8 cores, some of you are using like Core i3, Core i5, Core i7. GPUs contain like 15,000 cores. It's like crazy. So they could process a lot of parallel information, parallel data. And you know, I had to account for that frame rate, for when somebody's internet is down, when your internet is not able to pull enough data. If I had not done that, it would have been a major problem for most people that want to use it, because, not everybody has good internet connection and all of that. This is a use case. I was thinking about it even before I designed the product. Even before I started writing my code, I was already thinking about it, right? So you have to do the same. That's how software engineers think. You don't just build because you know how to build, you know how to write code, you can form a web page, you know how functions work and all of that. You really do have to plan before you start working. So the next thing is scalability, right? As our database grow, we want to ensure that the platform that we built, is manageable. Informations are being stored uh, correctly and retrieved correctly without crashing database, connections and all of that. If you don't store things well, sometimes, when your database is so big and so robust, like you've stored a lot of informations, you you will, tend to crash things if you are not storing things well. So planning is very important. At some point in this training, you would learn about SQL, you learn about NoSQL, you learn about Redis, MongoDB, PyMongo. They are like a lot of SQL stuff we have to teach you. It's already there in your training. It's just, I'm sure nobody is there yet, right? Except people in Quart 1. But a lot of you on this live stream should not be there yet. Um, you have to store things well. We'll teach you how to join. There's something they call joining two database tables. You take some information from one table, you take some information from another table to form a table. You could actually display it as an entire table. So you need to know how to store things. We are just what we are doing in this class. This is a preparatory class. We are giving you an overview of what you should be thinking about, things that you should be thinking like when you start working. From our next class, we'll actually start bash code. So we'll have an overview of how bash code works, you know. Okay, so let's go further. So scalability, very important. We want to ensure that, the database, the servers and all that traffic is managed very well such that we could upscale. It's very important. You need to think about your how good your database is. You need to think about firewalls such that the attackers don't flood your database. See, there are, sometimes you are not even expecting too much data on your database, as much data as can blow your database, but because it's not safe, because your server is not well protected, hackers could use malicious softwares to flood your database with a lot of information. And at some point, they've blown your storage, and it's something else. You know, it could be a major problem for you trying to solve that, especially when you have activities, financial activities on your platform, and you know they've blown your storage. That's crazy. I think it happened to somebody I know sometime ago. These are the things, use cases. I'm just giving you some analogies, things that you need to think about. You need to protect before you start coding. These are not things you do after you've written a line of code. These are things that you think about before you even write a line of code, right? So, maintainability, right? You need to write code in such a way that it's easy to maintain. I told you guys that the platform, the WinMingle community training platform that we use, was written like 8 years ago. I was a beginner when I wrote it, you know, and I could still bring it last year. I could still bring it out and be like, oh yeah, that's my code I was writing that time. Let's, do something about it. Let's do server maintenance and put it out there. I have the time for that now, and I have the experience level to train. So I was actually, it was not meant for software engineering training. The platform was meant for another training like that, not for software engineering at all. And with all my experience now, I decided, oh, let's whip it up and use it for software engineering. And the code worked. I did not have to struggle to understand anything in the code, right? I wrote every single line of code. I did not have to struggle. I did not have to spend a lot of time to understand the code that was there at all, you know. So it's very important for you to write code, very scalable code. If you watch your training materials or your assignments, you see that we have specifications as to how you should, write your code. We have specifications as to how you should comment on your code, even inside functions. Like, it's very important. You write a function and you don't comment on it. It's wrong, right? It's very wrong. You need to comment on every single thing, every single section of your code. Then you need to have a comment there. Very, very important. You need to do proper documentations. You need to have README files. A lot of you don't add README files to your repositories. A README file to guide you or guide any other engineer. Why this thing is very important is, should in case in the future your business grows, your platform, your software grows to the point where you can't manage it yourself anymore. It's easy for you to employ an engineer, because all the information that the engineer needs to understand to be able to upscale your platform is already there. Like, he could read them and understand them and work. So maintainability is very important. These are things that you plan for while drafting uh, the work. You really do need to plan for them. Another major thing that need to talk about is the software engineering mindset, you know, the engineering mindset. There are certain things that you cannot hold on to. Number one, we will talk about trade-off and decision making. Sometimes in your work, you realize that you cannot hold on to something that is really important to you. You know, there are certain information you want to display, but because of data storage, your storage capacity, you're not able to have such information, you know, you're not able to have such information uh, saved on your platform. So you need to, you know, outsource, maybe save the information on another platform that is built for data storage and pull in the links to your platform. Maybe that's not how you wanted to do it. You really wanted the program to be all the information to be on your platform, from your platform. Okay, let me give you an instance. Imagine that the videos we use to train you. I would have loved those videos to be saved on the WinMingle community platform, but because of scalability, because of storage capacity, I don't want to store them there anymore. The reason why I would have loved those videos to be saved on the WinMingle capacity is there are certain things I could do. I could re-edit the video using my code, and change some aspects of the video using programming languages. There's something you need to know, like there's uh, some libraries in Python that enables us to change videos. Like currently, I have an app that could, like a software in my platform that I built that could download a video and change things, change the meta information of the video, add a watermark, add a design, add something, add another video to the video. I don't have to do that. These are the things you guys pay graphic designers and animators for, right? I don't have to do any of that. I do them with my computer program. I have a computer program that handles all of that. So I would love my videos for the WinMingle Community Training Center, all the videos that we made that we use to train you guys to be saved on the server, because I could manipulate them how I like. But I don't want to do that, right? Because of space. I had to choose between scalability and uh, my ability to, manipulate the class materials anyhow I like. What did I want best? I wanted the users to have a swift and fast experience. That was what I wanted. Sometimes excessive storage reduces storage how fast your server loads as well. When you store a lot of data on your server, it reduces how fast your server loads. I know a lot of you would have noticed this from your phones. There's a level of storage that you would have, your phone will start hanging and start getting a little slow. you know it happens same way on servers, on hosting servers. It's hosting servers. What are hosting servers? Hosting servers are CPUs. You're just paying to use a CPU that is stacked somewhere. If you see the hosting companies, they have like a big room of thousands of computers stacked, together. So they have like a lot of processors, a lot of storage units, and all of that. That's basically how, you know it works. So what you're paying for usually when you pay for hosting is you're paying for a dedicated computer, a computer that will not go off, right? That's basically what you're paying for. So they'll attach a few cores to you, a few CPUs and storage units to you, and basically that's what it is, what hosting is all about, right? So trade-off and decision making, there are certain things that you could not have in your platform. You need to make a decision. Scalability over, you know, ability to manipulate your platform anyhow you want. I did that. I had to choose between those two in the WinMingle Community Training Center, right? And that's why you see the videos are being pulled in from YouTube, private YouTube link to your platform for you to watch, right? So I had to make a choice as well. You guys will get to the point in your journey where you would need to make a choice, right? So that's about trade-off and decision making. Problem solving, right? First solution engineering, you know, first solution engineering. Some people when they start building platforms, they focus much more on the system architecture. They focus much more on what languages they will use in building rather than the problems they are supposed to be solving. Like, what's more important is not your fancy programming language. What's more important is not how good you are a programmer. What's important is how easy your platform solves, you know, national problems, individual problems, organizational problems, world problems, right? So that's what software engineering is for. Software engineering is for problem solving, making work easier, faster, right? This is what people care about. So we don't really care about crazy architectures, crazy workflows, complex. All we want is solution, right? We want the program to actually solve problems, underlying, real world business demands. Your program should solve business demands. That's what's more important than your programming language. See, the language you're writing to build your product, right? Nobody actually knows the language that you're writing to build your product. Nobody actually knows the language that you are writing to build your product. Nobody. Only you know that information. Only you know that information. So you, yeah. So you have to choose the language that you are more comfortable in, the language that you understand, and use that language to build the product that you're building, to the problem you are trying to solve. You have to use that language that you understand most, and not trendy tech infrastructure, and then with time you would understand how best to, you know you would understand how best to be scalable, to, you know choose other languages when you are comfortable to write them. I'm still available. System level thinking, right? For programmers, we for programmers we need to bring ourselves while planning the system infrastructure and everything that you want to build. You need to bring yourself to think like the computer, right? This is how you realize majority of the problems that you would have in the course of doing your job of writing the software program. You're going to have a lot of problems, right? And the way that you fix these problems, the way that you know you solve these problems is by thinking about how the computer thinks. That's how you use that's how you realize some of the problems that you will be facing even before the computer starts throwing errors. It's very important for you to know problems that you have to face before the computer throw errors. There was this company that launched the software, and upon hosting it, upon deployment, their entire database structure was floated on the internet as a text file. And people that were available at the time on the internet while they were hosting, they downloaded the text file. So imagine having $1 million company's entire code base as a text file. You saw it and you downloaded the entire thing, right? Such a company became that company became so prone to attacks, and today they are out of business. This was because of lack of understanding. Engineer did not realize the problems that he was going to face before he faced them. So he actually hosted because of that's another thing we are going to talk about. Like, you don't need complex architectures. Like I just said it, you don't need trendy architectures. You have to host on languages and structures that you fully understand. The simpler, the better. The simpler, the better. Many a times you see junior engineers struggling with a lot of tech stuff, and we senior engineers just sit down and we be like, oh, okay. The work that take us one day takes junior engineers like 1 week, 1 month, 2 weeks. Why? Because of lack of planning. Junior engineers don't plan. They just start building. They move like they are. See, we do much more of planning than implementation. We do a lot more planning than implementation. This is what coding is about. Coding is logical reasoning. You need to understand what you are building before you implement anything, right? So because of systems level implementation and all of that, a multi-million dollar company had to shut down. Why? Engineers deployed on languages they were not comfortable with. And unfortunately, at some point, their entire code base was like a text file on the internet. And they started getting so much attacks, they had to wind up. They had to go back, shut down the entire business. And I think maybe they've started operation under another, like build from scratch. Like imagine you running a business where you earn daily, let's say 100 or a few $1,000s, 50 to $100,000 daily, and then you have to wind up. You have to stop operations entirely because engineer that was to do maintenance deployed the entire live platform, and it was a text file. You know, that could only happen when you don't have full understanding of the tech stack that you are using, right? So that's why we don't want anything ambiguous. We just want to solve problems. We want to understand what we are doing. We need to understand there has to be a lot of testing. You need to bring your knowledge down to this how the computer thinks. These APIs I am fetching, where are they stored? Are they secure? You know, how how are we testing them? I think I wrote it down. It's like API performance pipeline. How are we testing them? Client side UIs. Like you test client side UIs on every single device, to realize if everything is showing very well. Like there was an app I was using one time on a small phone that I had. That was some years ago. And I realized that there are certain features of that app that I could not access on my device because they were hidden for people like me that had small device, right? And people that had larger screen sizes could have like an holistic view. So your program has to be responsive. These are the things that we plan. These are the things that we think about, right? Uh, yeah. So before we go to the next section of the training, let's pause and have a brief discussion on what software products you have interacted with or which of them you interact with daily currently that demonstrates exceptional system engineering. By system engineering, we are talking about reliability, scalability, and maintainability. So are you guys there? What software program have you been using recently that has demonstrated scalability? You know, there are a lot of software programs currently in the world that we all use. Yeah, that reminds me. Today we are going to give one person the full scholarship as well. So stick with us till the end of the training. We are going to be giving somebody a full scholarship. It's very important. So what software programs have you been using? What application? What companies? There are a lot of the big companies actually, they all have very scalable programs and they do their deployments. They do their deployments without any issues, Facebook is always constant. They don't have to shut down on operations to do deployments and all of that. That's scalability. That's another level of of reliability. That's another level of reliability. So um that's that for that. Let's go further. We are running out of time, right? So the software development life cycle, right? We need to talk about the software development life cycle. And there are a few phases of the software development lifecycle. In the chat, you can leave. I asked you guys a question: what products you use, what software products that you guys use that has demonstrated reliability, scalability, and maintainability. That was the question that I asked. So somebody should do a chat. You could reply in the comment section. Um, yeah, the next thing that we are to talk about is the software development lifecycle, right? So there are a few phases of the software development lifecycle. This is really important. Like this is the most important aspect of this training that every software engineer should have at the back of their palm. You know. So the first question is what, right? The requirement analysis. So as a software engineer, you need to, as a software engineer in an employment, working in a company, building your own, you need to understand the desire of the stakeholders, right? And implement it. By implementing it, you need to break it down into specifications, into different units, into, API schemas, wireframes, into subunits. I just told you guys about having a base model and having other models calling the having the base model calling other models to form the full application work process. And the reason why we need the workflow to be separated is for easy maintenance, right? So let's say you have a problem with a particular section or a particular activity that the software is supposed to carry out. You should know the section of the brain that controls that that particular problem, and you go straight there. So imagine you have like 5 different controllers controlling different models, different problems, solving different problems. It's easier to do debugging. It's easier to upscale, to upgrade and update the platform. It's much easier. So software engineers should understand how to break down a complex idea into smaller independent or individual units. It's very important. The next thing is system architecture and design, right? So after you've understood the ambiguous idea of an employer as a software engineer, the next thing you want to think about is what system architecture you want to use in solving this problem. I kid you not, there was a program I built for someone. I did not have a database, but I was storing data like I had a database, right? So see what I did. I sat down and I planned. I was like, okay, this person needs this program, and this person is not willing to pay money for this program, and this person wants to be storing a lot of data. What do I do? There's a lot of constraints, right? You want to build a program that runs on the internet. You don't want to pay for database management. You don't want to pay for any hosting servers plan to have a database. You don't want to basically have a backend, right? You want to build with only front, in fact, basically only JavaScript. You want to build with only JavaScript, right? And you want to still store data like you had a complete database and all of that, right? What then do you do? So I built that platform and I was doing everything on the client side. And information that I really wanted to retain on the client side, I used to send them to a Google document, basically a Google spreadsheet, right? I used to send such information, any information that was important for the client, for the user, the admins to see, or later, let's say client data that we want to grab. I used to send it to a Google document. So the owner of the platform was using a front end um, uh, design to do business. And when people place things like orders and all of that, she used to have them in a Google document, in a spreadsheet. And trust me, she didn't have to pay a dime for hosting or all of that stuff. It was very scalable, very simple, very everything. See, it's easier to make things simple. The simpler you're able to make your job, the better for you, the better for your job, for your debugging and all that. You know, we'll talk about unit testing, we'll talk about testing, deployment, before deployments and all of that. We'll talk about the types of testing as well. But the easier you're able to make the job, the better for you as a software engineer, right? So I was able to do that. I was able to make a use a front end and still have a kind of backend. So, it was the backend was holistic. It had everything a businessman needed. Basically, as a businessman, what do you need from your clients? You need client information. You need client, aside from client information, you need the client. If the client places an order, you need the client's order as well, and all of that. So if you're running an e-commerce platform, you could actually run without database. Well, that's for people that don't have money, that just want. I think the simpler the better. Yeah, I could see somebody saying the simpler the better, right? So it's very important, very very important for us to keep things basic as possible, right? So let's go further. Then the next phase is the implementation phase. This is where programmers start. This is where, so usually, see the problem with most engineers here in Nigeria, why we are not able to upscale and grow, and in Africa as a whole, is when they tell you about software engineering, the first thing they tell you is phase three. They leave all of this, all of the planning, all of the architect. This is the foundation. Like this, step one and two. If step one and two is faulty, step three doesn't matter. You will not succeed. But then we usually start training ourselves from step three. That's why most engineers don't scale. If the foundation is faulty, the building is obviously going to collapse, right? So step three is very important. This is where we start implementation and all of that. We start the coding, implementing the coding logic. It has to do with it's a lot about syntax, right? Here I said this is the construction phase. Software engineers build modular, maintainable logic using strict syntax, internal coding standards, and collaborative code reviews, right? So all of this is very important. You start coding, you know, you start using strict syntax and all of that, internal coding standards, you set up a standard. When we say internal coding standards, sometimes you might be working with a team and you guys set up a standard. There's a standard to which you want to build, you want to write code, you want to write scripts. A typical standard might be the standard that we've placed in the WinMingle community. As part of the training, you'll see that we have standards. For every function, we want comments. For every repository, we want a README file. At the top of every file, we want comments. The reason we are doing this, these are our standards. We implemented them so that your code will be easy for you to read later. Employers, remember the reason why, like, if you don't understand what I mean by the WinMingle Community Training Center, it seems you are new here, you need to go join our training, at www.winmingle.com. That's where we have a well detailed step-by-step training for you. Yeah, so this is an overview. Here we come here to sharpen our minds. You need to go there so when I say certain things here, you don't feel lost, right? Okay, so like I was saying, implementation, coding standards. We need to implement standards, internal coding standards that will enable the user. While we were writing C in our platform, that reminds me, we implemented coding standards. We used GCC with a few flags, right? And some of the flags were to ensure that you know you fully understood the problems. I know that we were using .wero, we're using wero as well. It was, that was to make the compiler to treat warnings as errors. What that means is that for every warning, you're going to get an error message. Your code will not compile, and then you have to go fix it, right? So you understand how C sees C programming, how the computer sees C programming, and you understand all the conventions, and you start writing with the right ethics, right? So we use dash wall, dash mirror, dash extra. We used all a few flags. There are much more flags that if you go through the manual, the man documentation for the GCC, you would see how to use and what they are used for. But those were the few ones that we implemented. It was our standard. It was part of our standards. You know, we had um, standards for comments. We had a lot of standards. In fact, the way we teach you is a standardized pattern where recently, if you've gone far in C or even in Python, you would realize that we we use functions. We do a lot of functional programming. We teach you how to call functions. So you would know the benefits when you start doing your project 3, right? Your project 3, 4, and 5. That's when you understand the benefit of how we teach you, the structure we have set in place for you to learn and push everything to GitHub. So it's very important. Your GitHub needs to be growing because this is what employers will check to know that you are an active. If you apply for jobs nowadays in software engineering, nobody really cares about your certificates. What people care about is your portfolio, right? Two things they will ask you for: where is your LinkedIn? Where is your GitHub repo? Right? LinkedIn is still not as important as they say for software engineering. What's more important is GitHub repo. There's a level of GitHub repository that an employer will see, who will know that yes, this person has been working. You know, so the most important thing is your GitHub. That's why you have to push all your assignments, right, to GitHub. Very important, right? So let's go for that. The fourth one is verification and testing, right? There is something called quality assurance engineering. They call it QA engineering, quality assurance. We usually employ quality assurance engineers to test automated units like separate sections, if you are independent controllers or models, and ascertain the functionality if they would have a problem under a certain condition or different conditions, as the case may be, that they would use for the testing, the entire testing. It's very important, right? It's very, very important. Testing is very is in fact before deployment of a live product, before we launch a product on the internet, we do a lot of testing. We first of all deploy a test product, right? So there's a way we work usually. We want to deploy a full product, a software product on the internet. The first thing we do is to deploy a full test product, right? So the users and test quality assurance engineers are going to be on the platform testing it and giving us feedback, right? Seeing what problems there are on the platform, and we keep adjusting as to their specification. We keep doing adjusting till we have a fully functional product. Now, what this means is you don't just go live without tests. Unit tests are very important. Unit tests are for independent units, all the small parts, functions that you use, all the functions that you use. You test their return values, under every single condition to see that uh, such functions will not be broken by the users when crowd come to use the platform, right? So it's very important to do the testing, before integration. We need to understand how the platform works. Another thing that we need to do after testing and identifying system anomalies is deployment, right? We now deploy the platform after debugging and solving all problems. We need to deploy it. We need to float it on hosting servers, right? A lot of us in Nigeria use things like Namecheap, AWS. Some people host on like GoDaddy. There are a lot of hosting companies, right? There's this other one. What's the name of that one? I'm forgetting. Like just like a whole lot. You could actually do your hosting on your own too as well. We are teaching you a lot. We are teaching you how to host in Gene server, Apache, everything inside Docker. and all that. So you can actually do self-hosting, you know. The problem with self-hosting is you don't have a dedicated computer, that's the basic problem with self-hosting. So power supply is another problem. So from this part of the world, uh, self-hosting is not advisable. But you can do that. I did self-hosting at some point. There was a time I did self-hosting for a program that I was building. I wanted it to go live, for people to test it and use it for as well. I launched a mini competition, right? That was what it was. I wanted people to play the competition, and I wanted a winner to get a winner and all of that. I was to give out a prize. And I hosted that platform from my private uh, computer, right? I did not pay for any hosting platform, and it went live. People played the game, and you know, so that's basically what I'm saying. You could actually do self-hosting as well, and then after deployment, you now talk about maintenance and monitoring, right? So software engineers still do real-time analytics. We still fix bugs even when the users are already on the platform. you know we optimize the performance of the platform. That's why planning is very important. So now see, in phase 6, we are talking about performance optimization. Imagine you didn't plan well. At this point of performance optimization, you'll be frustrated. Why would you be frustrated? Your structure is wrong. Your structure is not built for scalability. So when you are done building an entire robust system, you now realize that there are certain things you cannot change because a lot of things are tied to them. And now when consumers are complaining, users are complaining that, hey, they want things in a certain way, you no longer be able to, you know, update the platform to solve their problems. Why? Because your step 1 and 2 was very wrong. So performance optimization is now going to be a problem, right? So performance optimization, very important, right? So there's another thing again, minor feature iterations. Post-launch minor feature iterations. So after you've launched a project and consumers, your customers, users start flooding your platform, you start getting feedback. Feedback is very important. After getting feedback, you now realize that there are certain things that you need to do in certain ways in order to, you know, make more money, or in order to upscale, in order to be in business or serve your customers, your users better. You need to change a lot of things in your platform. That's very, very important. So another thing we have to talk about is the software development lifecycle. What are the risks and rewards of, you know, adhering to the software development lifecycle? So the under the risks, or should we talk about rewards first? Let's be possible people. Let's be positive people. Let's talk about rewards, right? So predictable cycles. If you follow through with the life cycle correctly, the software development life cycle correctly, you would have predictable cycles. What that means is that you already predicted how the system is going to behave before you built it. You remember step 1 and 2, phase 1 and 2, where we predicted every single outcome, every possible outcome on paper and pen. Before we started using our fingers, we used paper and pen to predict every single outcome, every possible outcome. And then, right, the next thing is robust system. Remember where I told you in step 6, the system now starts getting so robust, we are still able to control it because we planned. We planned for this, right? We planned for 1 million users before we built the platform. We planned for 1 million users. Okay, the next part of it is faster onboarding. Faster onboarding means, imagine that you get a new engineer to join your team and you are able to, in fact, you don't even have to say much, and he can join your team and start working and be productive in 2 days. codes are somehow confusing. So if you start working for a software engineering company, one of the things that you'd realize really fast is that they give you a code that you struggle to understand it. And one of the reasons why you would struggle to understand the code is poor implementation of standards, structures, and good coding habits and conventions. You know, if you have good in your training, we are already implementing structures, we are already implementing standards, coding standards for you to follow while writing code, doing performing simple tasks that we use to teach you all coding concepts, programming concepts, right? If the company has good, you know, implementation of standards, conventions, and all of that, and they strictly adhere to it, it will be easier for them to adopt a new engineer. New developers can, start working, start designing, start updating their databases and all of that. They will know what handles what. Very important. So the risk of ignoring it is, unmanaged problem. If you don't plan before you start designing a structure, the structure of all database schemas, all your databases and all your projects, you would find out that it will be so fast for the program to, to explode and grow beyond your control. Very important. All beginners face this problem. If you don't plan very well, you don't plan for the crowd, things will start getting messy, right? Things will start getting very, very messy, and you would find it a little bit difficult to update your program at a point in time. The next thing is brittle architecture. This is pretty much what we are still talking about. Writing code without upfront architecture leads. It leads to rigid system. You know, you have rigid systems you cannot easily update. The systems will start breaking when you try to update them, and that's a very major problem, right? High cost of bug fix. So you now need a more experienced engineer. Imagine you were working with junior engineers, and now you need senior engineers to start working for you, because you're now making money, and at some point you need to spend like your 4 months, 6 months income on engineers or an engineering company to come fix a bug for you that you can no longer handle yourself. This happened in a company that I worked for. I came to work for them, and there's a part of their entire business that some Indians built for them, and the entire code was just somehow, it was like one long giant script. It was not scalable, it was not solving the problem anymore, and that entire section was scrapped. I had to build it entirely from the ground up. That was more cost for the company. If you're running your private business as a software engineer, that's more cost for you. So, another question before we go forward, we have a brief question here. Reflecting on the life cycle, the software development life cycle, which phase do you think is mostly frequent? Is most frequently cut short? You know, what phase do you think we usually cut short? What phase do you think we usually do not, you know, implement? We just want to run past it because of maybe deadlines or all of that. As a software engineer, what phase do you think you jump? I think the answer is very obvious. It's phase one and two, right? We all skip phase one and two because of time. We want to rush. And that's the problem. When you skip phase one and two because you want to rush, you now later realize that the whole thing is getting harder. The whole program is going to get more complex, very, very complex, that you at some point will regret skipping phase one and two. So I encourage all of us to always ensure that phase one and two is implemented before you start phase three, because we usually skip to phase three. Let me see a few comments from you guys before we go further. We have a few more things to talk about. So somebody was saying the simpler the better. Yes, the simpler the better. You need to, as much as possible, make your program as simple as possible. That's how you get the best out of your software product. Some other person is saying planning before implementation, very important. Somebody said first bank app, FCMB app. I don't know about FCMB mobile bank. I feel like that's for me one of the worst. Well, I don't know. I don't really know about their mobile app, but I know they usually don't have service. WhatsApp is very good. Like WhatsApp has all of us. Like it's so scalable. It has everybody on it, and you don't like. There's no glitch at all on the platform. Very important. Google, advanced. See, Google is not Google just because of their front end. If you take a look at Google's front end, it's usually very simple for the user. The user interface. See, that's what I'm trying to make you guys understand. Regardless of the robust infrastructure that Google has on the back end, their user interface is one of the simplest you can find in the world. You just come and you see a search bar, search anything you like. And even when you search things, all you see is just the heading and some text, the heading and some text, and all that. It's so simple, and the whole world depends on it. Trust me, as a search engine, the whole world depends on Google. Yeah, we talked about GCC at some point. Somebody is saying GCC, simple and clear messages and all that. Somebody said Netflix, YouTube. Yeah, these are the big companies, right? So the goal is to find out what these people are doing, why these people are so successful. These big companies that we are looking at, the goal is to find out why they are so successful. Yes, Israel said phase one and phase two. Phase one and phase two, we always keep them, right? Phase four is very underrated. Phase four is very, very underrated. Testing. And it's one of the most important steps. Phase four is one of the most important steps. That's why you need to write code with good coding conventions. You need to write unit tests, test per unit. You're doing functional programming, right? You are supposed to test per unit of the system brain. What a unit is a function, of your backend. A unit of your backend is like a function. You need to test every single function, and if a function breaks, the entire code is supposed to like break to tell you, hey, this function is not doing what it's supposed to do, right? This is how unit testing works. This is what we do in the testing phase. So in the testing phase, we use unit testing to ensure that every single function under every single condition works as intended, right? So that's that for that. We are supposed to go further in this training tonight. This is an overview. The class is getting long. We need to end this class very soon, but we have to talk about the things that we need to talk about so that in our next class we can delve straight into interpreters and bash scripting. Is very important for us to start talking about these things. So the next thing we have to talk about is the software development methodologies, right? So there's what we call a waterfall model. It's a kind of rigid coding pattern. You know, it's a phase. Imagine the project is being uh, imagine the project that we are building is being divided into different phases. Let's say phase one, phase two, and phase three. You have to complete phase one before you go to phase two, before you can touch anything in phase two, right? And one thing that is very important is while writing a product, there's something I do when I write code. I usually attack the most complicated part of the program before I do the easy ones. And then I think about how the complicated part interacts with all the easy parts of the program. If it works, then I start building the easy parts, right? And it saves me a lot of time. It saves me a lot of stress, a lot of errors. Sometimes you start a job, you start writing a program, and you get to a point where you now realize that you should not have started. And guess what? You had already spent like 1 month or 2 months or 3 weeks, as the case may be, struggling with the program. You know, when you do waterfall models, you have to fix a stage before you go to the next stage. It's rigid. It's very rigid. It's you know it's best suited for industries like the aerospace, you know. Many a times they write like single page documents. So imagine a program that users do not really interact with. It's meant for a particular uh, activity. Its outcome is usually predictable. Okay, let's say we want to write a program that moves a rocket from a rocket of a particular size from Nigeria to, or from Africa to uh, Asia. You know, such a code does not have users interacting with it. It does not have, all it does is you just want to push a button and it flies to Asia, right? To a particular point you've calculated. So it's a rigid kind of code implementation. It's different from the agile methodology. This interactive is flexible. Projects are broken into smaller cycles, yeah, and we 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 want to deliver, you know, all the different stages, all the different phases of the projects concurrently. We have a few teams working on certain different parts and all of that. And as well, we care about user implementation. The code is prone to change. The users can tell us, the software engineers, hey, uh, we want it this way, and we can change things. You know, it's different from when you're writing a code for a spaceship. You know, nobody is interacting with it on the user end except people that want to just fly it for a specific purpose that it's already programmed for, right? So changes are a little bit, you know, on the low side. We are not changing much in the code. It could be rigid, right? So for this agile methodology is best suited for SaaS platform. If you know what a SaaS platform is, have you ever heard of schools? Somebody implementing a program and having, you know, you build like a school management system and you go install your school management system for a few different schools, you know, and you are the one controlling it. The users, the schools, owners of the school pay you to gain access to your product, right? So that's how SaaS platform works, you know. Consumer applications, things that basically the market can evolve with. If you build such a project, it has to be an agile method, right? Because we need to be doing updating, a lot of updating and all of that. So there's another thing about software engineering. There's a Scrum framework. Uh, Here, engineers could be given like a period to tackle a particular phase. It could be 2 weeks. It could be the last project I worked on. We had phases, periods, you know, time frames to tackle a particular aspect of the business. The last thing we were trying to achieve on that program was we were implementing shipping APIs, right? Yes, we were somebody saying MVP. So um, we were implementing the we were implementing the what do they call it? Shipping APIs. Yes, we were implementing shipping APIs. Wanted to The business wanted to ship to like the entire world at large, so we needed to implement all shipping APIs of all major shipping distribution companies to ensure that the business could ship their product to all major countries of the world. You know, it was an e-commerce platform, a very big one. They are based in the US, right? And we had to share the work. Somebody had to work on other. I was working on the crypto payments, you know, aspect of it. People that choose crypto payments, I was integrating the shipping APIs for crypto payments, and some other people were implementing other aspects of it. That was how we divided the work. So what we were doing was we were having daily stand-ups as well. We were coming to tell ourselves, you know, what we've gained, like what we've done and what needed to be done, what aspects of our work we needed to, or what aspects of the other software engineer you're working with what aspect of his work he needed to modify to suit yours and all of that. So you have like some meetings, daily meetings to discuss about that. Uh, the next thing there was continuous evolution, right? So at the end of each phase of the building, the the program goes for testing, right? And then the owner of the platform could tell us, hey, okay, this phase he's not comfortable with this and that, and we still redo it and all of that. So it's we that's what the continuous evolution is like. Sprints, when we say it, sprints retrospectives, retrospectives is about continuous evolution, right? So the team is to build, like I said, we have the owner of the platform come do reviews, and we go back and fix the things that we didn't do well or the things we did well. That's basically how it feels like to work in a software engineering company. Kanban is just like a visual representation of the faces that the things that you are going to do is a visual representation, and it uses things like physical kind of boards to tell what you're doing now, what you've done, what you're going to do, and all of that. These are the things that we show employers, and work in progress, what you are currently doing. We 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 need to take that seriously as well, showing the current state of work, what we are going to do, what we are currently doing. These are the things that people do in software engineering companies. It's not much. This is not something we should talk too much about. Continuous flow, you know, we talk about how rigid Scrum is. Kanban acts as a continuous convoy belt, you know, very important. In this Kanban, when you do work in progress, the part that we are working on, we could, build it, and we have the user tell us that, oh, this is my specification, that is my specification. We go back and we redo it, but then there have to be a limit to it. If we don't put a time frame to, you guys are going to employ software engineers as well to work for you when your program is big, so you need to understand all these things. If you don't put a time frame as to when a particular work is going to be done, then software engineers could take even 6 months to build something they should build in 3 weeks, right? So work in progress needs to be limited. There needs to be like time. Uh, a brief question that we should ask to reflect ourselves on team dynamics is why limiting work in progress in Kanban is so critical for maintaining developer efficiency, right? I think that's the last thing I just said before turning to this screen of the slide. So limiting work in progress time is very important. You have to actually tell people. Remember, if you're building a house and you just do daily pay, some days the workmen might just come and they are so slow, they are not doing anything. Why? Because they know that at the end of the day you pay them that days. They want more days, so you keep paying them more, and we don't want that, right? Uh we want to you know have people work fast. People that are working for us, we want them to be fast. The job is not easy. We know it's very important. So if we don't limit work in the period for work in progress, we will keep going in circles, right? Let's see what you guys are saying in the comments, right? Somebody said, please sir, what is MVP, right? So MVP is when I said the launching a product. Test phase usually is the MVP we launch. We launch the minimum viable product, right? Is what we launch. Is like, what is the fastest? Like, okay, let me give you an example. Sometimes we work and we push an MVP, a minimum viable product, right? We push some features of the entire application. Imagine we are building an application that has 10 features. Out of the 10 features, the application needs 5 or 4 features to start. The rest of the features are, advanced features that we could actually start without implementing. Pushing out an MVP is pushing those first 4 so the business can start. We keep working on the remaining 6, and then we'll be pushing them one after the other. We'll do our code reviews on all the other aspects of the business that you want to push. So let's just imagine the feature is just a feature thing, right? WinMingle training. Let's use the WinMingle training. You guys all know the platform. What's the MVP? The MVP is your class materials, right? The the part of the program that pushes your class materials. You have a small social media there. That's not part of the MVP. That's something we can do later and add. The most important thing is user registration, you know, class materials. That's the most important thing. So MVP equal user registration and class material. Every other thing the Mimic community has on its platform, like the profiles, could be part of it because we have user registration, so you could as well just put a profile, right? So the chat environment, a little bit of other things that go on in the server, all of those things we use for management and all that, all those things can come later, right? So MVP is just the minimum viable product, what you need for a start, right? Let's see what is somebody else asking. Somebody is saying network in my area is unstable. Oh, sorry about that. The video is going to be on YouTube, so you can watch it anytime, right? Another person is saying phase 1, 2, and 3. Phase 3 is usually where people start. So phase 3 is not usually underrated, right? The last person is saying the job of Scrum Masters and project managers. Okay. Um, that's that for that. We still have a few more things to talk about before we get going. Um, so we are to talk about the 3 layers, the 3-tier architecture. The presentation layer, which is the front end, the application layer, which is the back end, and the data layer, which is the database. So these are the 3 major things that software engineers have to account for while building a platform, right? The entire platform that you built is just the front end, the back end, and the database. So the planning goes 3 ways. Your planning has to be for front end, how your front end will be, user appealing, you will be, user friendly, as simple as possible. It has to be simple. Simplicity is key. When people come online on the software engineering, the WinMingle software engineering training program, we basically almost have to teach them nothing because of how simple we made it. So simple, it does not have to be technical. The simpler, the better. The simpler, the more people can, you know, understand your product, and the more users you have on your. So try as much as possible. The next time you try to build a software platform, think about simplicity. Stop thinking about complexity. So for front end, we said the client side application directly on the user's browser. We all know this, right? It renders the user interfaces, manages responsive styling, captures user events, and that. So it's usually built in things like React, Vue, Swift, HTML, CSS, and JavaScript, right? So HTML, CSS, and JavaScript is the basic. These were the languages that software engineers started using to build this thing. But because HTML, CSS, and JavaScript is a little bit lengthy, sometimes software engineers are very lazy people. We like shortcuts for everything. We started implementing frameworks, right? So what is React.js? JavaScript framework, right? Vue, Swift, all of that things, all of those things is to make automation on the client side really easy, right? Sometimes it just looks like calling it. You could do JavaScript animation inside your front end code. You're going to get there, right? In this training, you get there. There are a lot of things we have to to write. This is why you need to take training serious. We have a lot to train. Um, for the application layer, which I said is the backend, that's the server-side computational engine where you calculate things. So there are a lot of things you calculate in your backend. You know, hey, which users have paid? After users have paid, what and what should we be saving in the database? When is this payment expiring? When is payment, due? And all of that, you need to calculate them in the server side. So there are a lot of language calculations that should be done, and all these calculations are to be stored in the third layer, stored and retrieved as well in the third layer, which is the data layer, the database, right? So the database is a storage engine. Is built for persistence to make you always have uh, the informations that you want, to make you always have this information that you want from your users. you know if you want information to be persistent, you don't want your system to be forgetting things, then you need a good database, right? So it structures, updates, retrieves, and maintains files, assets, structured tabular in a structured tabular data format, and it's managed by uh, uh, Postgres, MongoDB, Redis, and DynamoDB. So there are like a few things. We are teaching a few of this uh, in your. We cannot teach you every single database structure. Yes, we are teaching you SQL Alchemy, we are teaching you MongoDB, we are teaching you Redis, NoSQL. We are teaching you a lot anyways. There are still a lot you need to learn. The major things is when you learn and you understand how to use um, programming functions, programming concepts and conventions, you'll be able to use more languages. Spread there are over 1,000 languages. If we decide to teach you all of them, trust me, this training will not end. We will not be able to set an end, and I won't be able to prepare all the materials for all of them as well. So we've prepared the materials for a very comprehensive training that will ensure that by the time you are done, you'll be able to work anywhere. You'll be able to upscale to build anything that you want and learn any new language that you want. You just need to do all our class materials in your training. You need to do all your assignments, read all our class materials, and spend time learning. Don't wait for me to teach you everything. Spend time learning. When I point you to the direction you should be looking at, the direction you should be learning, I expect you to go learn with or without my availability. I expect you to go and learn. It's very, very important, right? The next thing here, SQL versus no SQL. SQL is like a relational database. It has to do with tabular schemas, right? We are talking about the part three, the third layer here. You know, it has a lot of tables and all of that, and you can save data, collect data. It's good for a lot of stuff. A lot of companies use it. Like most companies, trust me, use SQL. In this training, we are teaching you how to use both SQL and no SQL as well. So depending on how you want data to be structured, if your data storage is not that complex and there are a lot of things that you want to store, SQL is fine. Using tables and all of that is fine. MySQL, SQLite, Postgres, it's fine, right? But then if your data storage is so complex and you are storing like a lot of data, right? NoSQL is easier, it's faster. So just imagine when your database storage gets so long and you're using SQL, right? We are talking about scalability. We want the software program to be so fast. If you're using SQL, like relational databases, you'd realize that you have to look through a lot of data. Imagine somebody that, okay, imagine Facebook's database. Facebook has billions of people registered on it, right? So imagine having to go through, having your processor to go through like a billion information to look for somebody that registered the 500 million uh, the user with user ID 500 million. Imagine you were trying to grab the user with ID of 500 million. That's crazy. That's a lot of information that you have to go through before you can get a single information. So people like that can't use relational databases anymore. They have to opt for no SQL. You're going to learn a lot about that in your training when you get there, right? So if you're not yet there yet, head to the WinMingle software engineering training and go take your classes. Very important, right? So NoSQL is flexible. It uses like JSON, key value pairs, to access data. So for NoSQL, the computer does not actually need to go through all the millions, hundreds of millions of data that has been stored, or users' information that has been stored, for the computer to be able to, you know, fetch a user in the middle, to fetch the user with user ID of 500 million. The user can just use a key value pair and graphical method and all of that scheme. As you'd see, it's already in your training, and this is just an overview. So we usually use things like Cassandra, Redis, MongoDB, and all of that. It's really nice when you start doing things like PyMongo. It's really nice. If you're writing Python code, it looks like Python functions that you write for database queries. It's not like SQL. It's a little bit different. It's nice. You get there. When you get there, you understand what I'm saying much more. But for now, these are the things that we think about when we write program, or when we decide what tech architecture we want to use to build our products, right? The next thing that we need to know about is like an abstraction layer. APIs are application programming interfaces. They are like abstraction layers. This APIs are used to connect with, other companies. You could want to have another company information, or another company provide a service for you on your software engineering platform. It's through their API they pass to you all the information that they want you to have, and you pass to them all the information that they want from you. They, from their end, will solve the problem. Just like the Women Community Training Center, we have an API. We use Paystack, right, for payments. Paystack has their own code. We collected their APIs and we fed them the information that they need from our own database, so they can be accepting payments and uh, sending those payments to us, right? So that's what APIs are used for. They are used for sending and transferring informations, right? So that's for that. There are a few more things I should have talked about this slide, but I don't want to go too deep into these things because we would get confused considering our current level. And as such, I just want things to be basic, right? So I said something like, let's explore dependencies. If your relational SQL database is experiencing heavy latency during very lookups, query lookups, how can front-end strategies like client-side chatting and loaders mitigate the impact of user experience? Okay, this question actually requires me to talk about front-end storage and all of that. So in the previous slide, I skipped some things. I skipped front-end dispatches and all of that, HTTP requests. I didn't talk about these things. So in the previous slide, from your front end, you could actually um, save things on your front end, right? I'm going to explain this question. I'm not going to let you guys answer it. I'm going to answer it myself, you know, because it's a little bit technical for beginners, right? So your backend is so slow because it's always it's always like querying. There's always a query going on in your backend, and then you start having problems. One of the ways that you can mitigate against these problems is client-side caching, right? Use like the cache memory, and after caching stuff, they are on like saved as maybe cookies or something, and then you do like a queue. You queue it to the database. That way, the database will start processing the information at its own time and at its own speed. Don't forget, many a times you pay money for hosting on places like Namecheap, and they like give you a processor that could only process a particular amount. If you're not paying for a dedicated server or a VPS server, your server could only process a particular amount of concurrent requests. That's to say that you need to understand how data is being stored and retrieved. If 50 persons, probably on Namecheap smallest plan, I think the total number of concurrent requests is 50 persons, 50 requests. So imagine 50 individuals concurrently on your platform requesting for, you know, a database query and all that. Your database is going to start getting slow, right? Very slow hanging, because it has to process. You have limits, right? So for you to fix that, there are certain things that you should do, and these are the things that you learn while in training. When building your third project, there's something we taught you guys, something we did. We used the file system to do the database, right? We use the file system to store things with JSON as JSON objects, right? And then later we updated the system to start storing in databases. So sometimes you want to like queue stuff, write them into the files, queue them before you systematically feed such informations to the database. Sometimes you want to queue things in user client side. You want to cache some things that are not really important. The only things you want to save on the fly are information that are really important, such as payment and all of that, right? So these are the things that we would want to do on the client end, right? This is part of planning. We are still talking about planning, right? We want to do implement these things in the client end such that we could relieve the database of processing requests, database queries. Since maybe you're on a small server on Namecheap or any of these hosting services, and they give you a concurrent request, uh, a concurrent, like a 50 concurrent request limit, right? Because of this limit that you have, you want to implement structures that will enable you to manage or get the best use out of this limit that you have. It's very important. There are a lot of things, like I built one of, remember when we had this X Empire and all of that going on, the crypto stuff. I built one of the applications, and the game we had to play, like there were like a lot of people, playing at the time in their millions, right? So I had to do a lot of chatting. I could not do database requests for everybody that is scoring. I needed to store a lot on client side, because you store on client side and you later move it to the database. It's easier for the database to handle. In fact, the time we had the day of the launch, we had a lot of database requests. Like my server had to, I I actually needed to opt for 3 more servers to add to the hosting server, and it was like routing and depending. So what I was doing was, a new client comes, and the one of the primary server was like a load balancer. It was routing the users to the different servers, the 2 other servers that I had. You know, these are what senior engineers think. Like, these are the things you need to plan before you start implementing your code. It's very important. So all of this should be thought about even before you start writing code. Now, the reason I was able to do that, the reason I was able to manage that crowd, was because I planned for it. I expected it. I already saw my predecessors had done it, and the crowd was that crazy. So I knew that the day of the launch, the crowd would be that much. I planned for the extra servers. I built the database schemas and load balancers such that I could route the load to the other servers and all of that. It's part of systems engineering. I am implementing that. You guys are going to do that in training as well. So it's all there. If you go to your calendar and you scroll to the end, you see all of these topics coming in your class materials and assignments. So take them seriously, right? Some people are feeling frustrated. The class is crazy intensive. It has to be. It has to be. Trust me. This is why I started this meeting by telling you that AI cannot build the software and manage it for you. You see all of those adverts you guys are seeing on the internet. Hey, I prompted AI and AI built my application and now I'm making money. Who is using your app? Who is using your app? They are just advertising the AI for you or advertising a course. They want to teach you how to use AI, how to prompt ChatGPT and tell ChatGPT to build a website. The person does not have money. Software engineering is not paying the person. His intent is to make money from you, from teaching you how to prompt ChatGPT. That's his intent. So you have to learn. There are no two ways about it. There's no easy way. Software AIs are making our work easier. The individual units of your code that you need to write, AI can make you faster because you can be asking him debugging faster, all of that, but AI does not cut it. AI does not save you of all the stress. I'm telling you from the senior engineer point of view. And very soon I'll start teaching you guys using AIs as well, using to make our code and our work faster. But then I'm still telling you, AI cannot make you a success. You have to make yourself a success. You have to be aware of all of these concepts, all of these problems. AIs are not going to tell you load balancer and all of that. And the AIs don't do that. Trust me. If you want to succeed as a software engineer, you need to understand what we are talking about. Yes. So another thing that we need to talk about, there are like a lot of things, right? Uh, I'm trying to end this live stream as fast as possible. It's been almost 2 hours. Continuous integration and continuous development. This we've talked about stuff that cover all of this stuff. Yes. So career roles. I think we already know what front end engineers do and what back end engineers do. I talked about it in passing, right? And tech stack, let's just mention some of the tech stack. We said front-end engineers use things like React, Next.js, Vue, CSS, TypeScript. In this training, you're learning TypeScript, you're learning React, you're learning CSS as well. So the only things that we didn't include is Next.js and Vue. Those are left for you to go learn. We cannot teach you everything because it will increase the time frame of the training. We have a lot. There's a whole lot for you guys to master. For backend engineers, you're learning like Postgres, SQL, Redis, Docker, Go, and Node.js. So yes, we are teaching you Node.js. We are teaching you Python, Redis, and Docker. So Postgres, SQL as well. You can take time to understand exactly how everything works on your own. And that's that for that, right? So you could actually be a full stack developer, which we are hoping that you become at the end of your training, to do both front end and back end. There are DevOps engineers, people that concentrate on systems, the systems engineering, how to scale, and all of that stuff. Heavy load management. We are teaching you that as well. You are going to learn how to implement a load balancer and all of that at the advanced part of your training. So it's very important. We are teaching you with DevOps. That's why we didn't allow you guys to start with VS Code and all of that. The idea is all these integrated development environments make software engineers in training to not understand DevOps engineering. We don't want that to be your case. Using VS Code and any other Atom, as the case may be, it's something that's easy. You can use it any day, anytime to write code. It's just for scripting and all of that. Sometimes you can put dependencies in your computer, like plugins and all of that, that correct your code on the fly. You can still do that in your terminal, even in the VIs and Nano and all of that, Emacs. that we taught you. Oh, I didn't include Nano. I'm going to teach you guys Nano when we start talking about in our subsequent classes. When we start talking about bash scripting and text editors, I'll take my time to talk about Nano as well, because I didn't talk about it. And Nano is very good as well. It's efficient. I didn't talk about it in your training. So there's a whole lot that we have to be talking about. We have data and AI engineering. So some people do machine learning. Some people do a lot of training of AIs and all of that. Some people, there's just a lot of stuff. So training of AIs are just uh, a lot of database storage and all of that. What are AIs? The language models that you use, such as ChatGPT, Gemini, and all that, what are they? You think they understand the information they give you? They don't. ChatGPT, if you go and search a prompt on ChatGPT, ChatGPT shows you a very comprehensive message about what you searched, about whatever you want to learn. But ChatGPT himself does not understand it. See how the architecture is built, right? It's all ChatGPT understands are independent characters. So it's matching your question with independent. So ChatGPT checks the W first, and then it checks his database. He cross-checks his database and he sees like a billion W's. And then he checks the H. That's his training. It will see WH, another 1 billion results. It will check that way till it completes the first word, what, and it will see 1 billion results in his database. It will now add the space and it checks individual characters. What is software engineering? So by the time it's done checking, cross-checking its entire database, it will now see the complete data of everybody that have talked about what is software engineering, and it will pack all the information to give to you. It will just arrange it. It will prioritize it. There's like a system for prioritization. It depends on the core settings. If you go to your ChatGPT, the settings in your ChatGPT, you could actually set it. They, they give you the opportunity to add some settings to make ChatGPT behave in some certain ways that you want as well. So ChatGPT is going to prioritize the information in its database, which is a lot of information. That's what AI training is data storage. I think I wrote something about it. Builds high throughput database pipelines, model data lakes, trains machine, learning neural networks and structure complex data schemas, right? So these database storage, machine learning is just about storing information. You store a lot of information on the database, and the machine is to like go through all those information to understand what to do per time a problem is faced. The machine is faced with a problem. It goes through all the information. So ChatGPT's training is like a bunch of information. It has a lot of resources. That's why if you ask ChatGPT anything, it's going to show you the resource where it's bringing out the information from, right? So it's not like he understands everything, but he has all the information at his disposal to bring to you, right? So that's what AI engineers does. They do a lot of machine learning and all that, right? So as for career paths, you could be an individual contributor working as a software engineer in a company, and as well you could, you know, be a manager. You could be a software engineer. So if you want to work as an individual uh, contributor, your programming knowledge is enough. But if you want to work as, a manager, an engineering manager, you need to understand how, systems are built. You need to understand, you know, a lot. There's just a whole lot. Every single thing that we just talked about, how systems are designed, quality assurance, what, you know, customers want and all of this stuff. I talk about simplicity a lot over robustness, especially of user interfaces and user interaction. You can have a very robust backend, but I don't see any need having a robust front end. Your front end has to be as easy as possible, regardless of how robust the information you want to feed to the user is. You know, these are the ways that senior engineers think about software engineering. You know, that's that. There are a few more things that we should talk about, but I feel like we should leave that for our next class because we've used 2 hours today to go through this training. materials that we have prepared. So before I go, I would have to focus on you guys. Yeah. So that's that for that. We talked about a lot of things. It's software engineering is all encompassing. Like there's a whole lot. One day is not enough to do an overview, right? One day is not enough to do an overview. So somebody, let's see what you guys are saying. Do you guys have questions? If you have questions, you could leave them in the chat for me to answer. I'm available to take a few questions before we move a motion for adjournment. Yes, so I left a message saying that we now have a Telegram channel, right? I want us to converge using a Telegram channel because the Telegram channel is easy to link to a group chat, right? To a Telegram group. So it's going to be easier for us to disseminate information in the Telegram channel. So I'm going to post. What's this? I'm going to post the link to the Telegram channel for us to join. Where is that? Please, you can keep your questions coming in. I'm open to take a few questions before I leave. Anybody has a question for me? So somebody is saying, was the most detailed class paid for so far on software engineering? Other classes based on explanation on learning programming language, deployment tools like GitHub and the rest, right? The WinMingle community training program is very detailed, right? We are serious about programming. We teach every single aspect, right? We teach every aspect of programming. We talk about deployments. We don't just talk about these things. The training is built such that the no, that Telegram link is wrong. I'm trying to look for the right one to bring to give to you guys. That link is actually wrong. Let me go get the right link. I don't know how that link got there. Anyways, oh, it can't be. It has to be on my phone. Okay, no problem. Um, I don't have Telegram on this phone. I just realized. And the other phone is what we are using for the live stream. So I would have to give you guys the link on WhatsApp platform or I'll post it. I'll post it in the comment section of this video after the video, right? So we can still have the link after the video to the Telegram channel where we'll have more detailed debugging sessions and all of that. So yes, we are very comprehensive. The training materials that we do, CD, meaning of CD and CI. So continuous integration, continuous development. You would, don't worry, we'll talk about the things. When next we come, we'll talk about the things that we didn't talk about this time around, right? And my brain is already, getting slow because I've been talking for the past 2 hours. Man, lecturers try a lot, man. But I want people in this community to grow. I want people in this community to start writing complex code as well. Building complex products is very important. So I urge you all, make sure that you are on the platform, make sure that you're learning, make sure that you take training seriously. Very important to me. Very, very important. I want everyone, every single one of us to grow, right? So that's that for that. Without the questions, I would have to take my leave and get you guys the Telegram channel. I think the name of the Telegram channel is WinMingle Communities. You know, let's see if I could. No, 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 I can't. I don't think I can actually do that. Do I have Telegram on this laptop? Okay, I guess I do, and I've not opened it in a while. Right? So somebody is saying, "My God." Oh, okay. That's the same person saying it was the most difficult, comprehensive class, detailed class he has joined. Yes, this is actually supposed to be one of the most detailed class available. We also have the most detailed training as well. We encourage users, every single user, we encourage you guys to go learn, go take your training seriously. Go to www.winmingle.com and start learning. Very important. Go start learning. Have a structure. The reason why you need to be on the platform, why you need to be learning on the platform is because this is how you build a portfolio, right? This is how you build your, software engineering portfolio. Employers will see that you're good at what you do. You as well will have good documentation of every single thing that you've learned. Very important. Very, very important. You need to build stuff. Software engineering projects, it's not just about building calculators and all of that. It's about the major projects. We brought out three major projects to train you on fundamentals, including front and backend plus deployment. We also have created time to guide you through your own personal development, personal project pitch and development and all of that. So training is very important, right? After all of this, make sure that you go to take your training seriously and we'll take it from there. Without any further questions, I want to bring this class to an end, right? So do have a good rest of the day, everybody. And yeah, that reminds me, for the people available today, is there anybody with a 200? Anybody with currently on the live stream? You've got uh 200 consistency score on your training portal. You have an active portal and everything. Is there anybody with such records, such good records? We have a gift for you. Is there anybody today on the platform, on the training? You've got 200 consistency score, and as well you have 200 consistency score. You are in training. You've been on this class and you have 200 consistency score. Yes, somebody, I'm seeing people with 200 consistency score. A lot of people. Afolabi Samuel and a lot of people. Yeah. Okay. 200 consistency score. Anybody on this training having 200 consistency score? I'm seeing some people sending me some private messages. So let's go see. 200 consistency score. Okay, so I have a few messages in my DM saying that they have 200 consistency score. This one said he has always been on 200 for like a while. So, but we need one person, right? We need one person. We can't give everybody. I promised everybody, not just one person. Okay. So I have a minimum of 4 persons currently that has 200 consistency score already in my DM. Adeyemi is there, right? Samuel is there. Uh, what is this other person? I don't know. This person is only sent me a WhatsApp message. I don't know who he is from the live chat. All right. Um, I'm going to do okay. Cosmo is there. Okay, I'm going to do you guys that have DM'd me. I'm going to text all of you tomorrow to ensure that one of you qualifies for my scholarship, right? So that's what it is. Send me a DM tomorrow morning, all of you, and then I'll pick out one person as well. Uh, with all of this said and done, I beg to take my leave. Good night, guys. We continue tomorrow. We have a lot to learn. Next week, we are going to be talking about the black screens, right? So we're talking about a lot of interpreters. We talk about bash scripting, a whole lot, and it's going to be practical. I'm going to be writing code as well alongside. So we have a lot to talk about the system behavior, how the interpreter understands what we are doing. There's like a whole lot that we need to talk about. So that's that for that. All of you that are available that qualifies for this scholarship today the class got so long and we were not able to do something, maybe an activity that we can use to scrutinize all of you. So I'm going to scrutinize you guys in my DM and give one person the scholarship as well. I'm going to post the WhatsApp group as well. On the WhatsApp group, I'm going to post the Telegram channel. Very important. So see you all next week, Saturday, when we talk about, see, Emmanuel is here as well, and he's saying he has 200. Okay, so I think we need to add another condition, another clause to the people that we are giving the scholarships, people that would qualify for scholarships. We need to add another condition because everybody is now qualifying, and we have to be giving one person every time, not everybody at the same time, right? Or remember when we started this for people in cohort 2, I guess, right? Or cohort 3, when we started this consistency score, it was a little bit more difficult because if you come today and you don't come tomorrow, your score for today, you lose it. But now people complained, they were like, hey, it's making them overwork. So we reduced it to 3 days. You would skip 3 days before your consistency score would drop by 3%, right? And it's now easy to grow the consistency score. That's why everybody has 200. So we are either going to go back and make the consistency score a little bit difficult, but then we are still not going to penalize you guys. It's just that if you can maintain the high consistency score, we give you the scholarship, right? So there's no penalty for not having the high consistency score. Anna is here. Anna Amor is here as well, and she has 200 consistency score, right? So we have a lot of you. We need to scrutinize. Okay, see what we'll do. We are going to go tighten the consistency score algorithm, right? We'll make the code to be a little bit strict such that everybody cannot just be on 200 unless they are working, unless they are putting in the work, right? That's what we'll do. Why do I forget what I learned easily? Why does it seem that why does it seem that logic come easy for some? Oh, okay. Logic does not actually come easy. Somebody is saying, why does it seem like some people understand logic easily and some people don't? You know, logic does not actually come easy. Logic is trained. You have to train yourself for logical reasoning. I was a software engineer. When I told my boss that I was going to do uh, another degree, my first degree was in accounting. Then I got a degree in software engineering, and then I went back to do masters in accounting as well. You know, when I told my boss I was going back to do masters, he was like, "Hi, you will learn faster because your brain now understands faster. Your brain assimilates faster. The way your brain works, trust me, you understand things faster." My brain was not as sharp as it is now. I had to train. It was a gradual process. So some of us were trained in ways, or some of us carried out activities that enabled our brain to develop faster, and some of us did not. So if now is the time for you to be developing your brain for retention and all of that, do it. Just keep doing it. Don't beat yourself. You don't have to be too fast. You don't have to understand fast. The best programmer, we are still talking about programming overview. The best software engineers and programmers are not the ones that have the entire code in their head. They are the ones that know where to find it. In the WinMingle software engineering training, we show you documentations. We show you where to go learn, you know, how to write code, where to find for back scripting, all the man documentation we show to you. We as well, when we teach you other topics, we don't just give you videos, we show you documentations where to go read about everything concerning functions, concerning pointers, concerning all of that, your installations and all that. You don't have to cram anything, you just need to know where to find the solution to your problem per time, right? Somebody is saying, please, I have a question, sir. My question is age a barrier in becoming a software engineer? Okay, I'll talk about you after talking about the person that's talking about comprehension. So comprehending things is not difficult. You can actually comprehend anything. You just have to understand that since it's the first time you're beginning to struggle with technical things, it's natural that it seems uneasy for you. But when you keep doing it, you're going to grow. Complete the training. I'm sure by the time you complete the training, not with the help of AIs all the time, use AI to understand what you are doing. Have AI teach you, understand it, and then you know you will be good to go. You'll be able to you know understand. Take your time. Don't beat yourself. Don't be too fast, right? Be slow. Slow and steady wins the race. The most important thing is consistency. It's not about how fast, right? Just be consistent. Implement only one functionality a day is much more important than not implementing anything or trying to get it all at once. Somebody is saying, is age a barrier? No, age is not a barrier, right? Age is not a barrier. At whatever age that you are, you will be able to um, build any software you want, or learn this skill. It's very important. The only problem that you will be having if you're an older person trying to learn this skill is the problem of time management, right? That's the problem most people have. Last time I told you guys to go read a book when I was talking about business. We will still create time to talk about business and much more things that you people need to know before you can manage a software business, because you need to learn the business of the business. For this person talking about age, the major problem with age is responsibility. You now have responsibilities. So learning a skill as software engineering that requires consistency, time, and you know, a lot of concentration becomes like a problem because you have responsibilities. You need to actually make money. Software engineering is not going to pay you today until you invest time. That's why I encourage people to see software engineering as a lifestyle, not a means to an end. If you see software engineering as a means to an end, just to make money, a pathway to greatness, so you want to rush into it to get the money, you might never get there. But then, if it's a lifestyle to you to always learn, always grow, you would grow into a point where your value now gives money. Who you are now make the money to come around, right? That's the point where I am in life. I am at the stage where I don't need to actually struggle too much. My years of struggle is now speaking for me, right? And that's where you can get there as well, regardless of your age currently. The lessons are all there. You just need to create time to learn. I think what you need to do is you need to read a book. I'll keep recommending books for you. You go read Atomic Habits, right? You need to go read Atomic Habits and understand time management. Atomic Habits will teach you about time management. I think it was written by James Clear, right? Yes, I think James Clear. So go read Atomic Habits. It's going to teach you how to manage your time, because that's the problem with most people. Most people whose age has gone far and they want to learn skills as such. You need to create time. There's this thing I used to do then. I used to do this 2 hour thing for the day where I spend 2 hours learning a new skill. I spend 2 hours developing myself in ways that, are unconventional, for the day. So for the day, even if I don't know what I do the entire day, at least I know what I do for that 2 hours. If you calculate those 2 hours that I spend for the day developing myself in a new skill or a new path, career path, and all of that, you realize that I have created an extra month, because 2 hours every day for 1 year is like 1 month. I created an extra month for myself for the year. That's how it feels. So I don't feel like same level with my equals, right? Because of consistency. Those 2 hours in the night that everybody is asleep and I'm still awake working, you know. When you're doing there are certain things that you do. Sometimes maybe you train, might be somebody that goes to the gym or something, or do there are certain things you could do together, activities that you could carry out together, you know. You need to tie those activities together and always keep doing them. These are some of the things that you learn in the book Atomic Habits that I just told you guys to go learn, to go read, especially for people thinking about time management. If you're still thinking about time management, you need to read Atomic Habits. Very, very important. So go get the book, right? Read it. It's by James Clear. And tell me in our future class what you thought about the book after reading it. It's very important. So, with the absence of any further question, I beg to take my leave. I'm actually going to run off before somebody drops in another question, because I'll be forced to answer again, right? So, good night, everybody. I'll see you all in our next class. Have a good rest of the day.